In this video, I am going to talk about the threads. The threads are a popular way to improve application performance through parallelism. In traditional operating system, the basic unit of CPU utilization is a process. Each process has its own program counter, its own register states, its own stack, and its own address space. On the other hand, in operating system with the threads facility, the basic unit of CPU utilization is a thread. In this operating system, a process consists of an address space and one or more threads of control. Each thread of a process has its own program counter, its own register states, its own stack. But all the threads of a process share the same address space, hence they also share the same global variables. A thread is a light-weighted process. The analogy is thread is to process as process is to machine. Each thread runs sequentially and has its own program counter and stack and to keep track of where it is. The threads share the CPU just as processes do. First one thread runs, then another does. Threads can create child threads and can block waiting for system calls to complete. Threads are a popular way to improve application performance through parallelism. In traditional operating system, the basic unit of CPU utilization is a process. Each process has its own program counter, its own register states, its own stack, and its own address space also. On the other hand, in operating system with the threads facility, the basic unit of CPU utilization is a thread. In this operating system, a process consists of an address space and one or more threads of control. Each thread of a process has its own program counter, its own register states, and its own stack. But all the threads of a process share the same address space. Hence, they also share the same global variables. Per thread and per process concept, per thread item, program counter, stack, register set, child threads, state. Per process items are address space, global variables, open files, child processes, timers, signals, semaphores, and accounting information. The dispatches workers model. We have already seen the use of this model in designing the server process. In this model, the process consists of a single dispatcher thread and multiple worker threads. The dispatcher thread can accept requests from clients and after examining the request, dispatches the request to one of the free worker threads for further processing of the request. Each worker thread works on a different client request. Therefore, multiple client requests can be processed in parallel. An example is shown in this diagram. Second team model. In this model, all threads behave as equals in the sense that there is no dispatcher worker relationship for processing clients requests. Each thread gets and processes clients requests on its own. This model is often used for implementing specialized threads within the process. Third, pipeline model. This model is useful for applications based on the producer-consumer model, in which the output data generated by one part of the application is used as input for another part of the application. In this model, the threads of a process are organized as a pipeline so that the output data generated by the first thread is used for processing by the second thread. The output of the second thread is used for processing by the third thread and so on. Design issues for threads packages. A set of primitives available to the user relating to a thread is called a thread package. Static threaders, the choice of how many threads there will be is made when the program is written or when it is compiled. Each thread is allocated a fixed stack. This approach is simple but inflexible. Dynamic thread means it allows threads to be created and destroyed on the fly during the execution. Mutex. A mutex variable is like a binary semaphore that is always in one of two states, looked and or unlocked. A thread that wants to execute in critical region platforms a lock operation on the corresponding mutex variable. If the mutex variable is in the unlocked state, the lock operation succeeds and the state of the mutex variable changes from unlocked to locked in a single atomic action. After this, the thread can execute in the critical region. However, if the mutex variable is already a lock, depending on the implementation, the lock operation is handled in one of the following way. Number one, the thread is blocked and entered in a queue of threads waiting on the mutex variable. Number two, the status code indicating failure is returned to the thread. In this case, the thread has a flexibility to continue with some other job. However, to enter the critical region, the thread has to keep retrying to lock the mutex variable until it succeeds. Scheduler activations. Scheduler activations combine the advantage of user thread and kernel thread. The goals of scheduler activation are to mimic the functionality of kernel threads, but with the better performance and greater flexibility usually associated with the thread packages implemented user space. Efficiency is achieved by avoiding unnecessary transition between user and kernel space. If a thread blocks the user space, runtime system can schedule a new one by itself. The workstation model. The system consists of workstations scattered throughout a building or campus and connected by a high-speed LAN. The systems in which workstations have a local disk are called diskful workstations or disky workstations, otherwise diskless workstations. If the workstations are diskless, the file system must be implemented by one or more remote file servers. Diskless workstations are cheaper. Ease of maintenance, installing new release of program on several servers, then on hundreds of machines. Backup and hardware maintenance is also simpler. Diskless does not have fans and noises. Diskless provides symmetry and flexibility. We can use any machine and access your files because all the files are in the server. Advantages, it is low cost, then easy hardware and software maintenance, symmetry and flexibility. And disadvantage side is heavy network usage, file servers may become bottleneck. Diskful workstation. The disks in the diskful workstation are used in one of the four ways. Number one, paging and temporary files. The advantage is reduce the workload, network load, and over diskless case. Disadvantage is higher cost due to large number of disks needed. Number two, paging, temporary files and system binaries. Advantages reduces network load even more. Advantage side is higher cost. Number three, paging, temporary file system binaries and file caching. Advantages still lower network load. Disadvantage higher cost. Number four, complete local file system. Advantages have hardly any network load. Disadvantages loss of transparency. The earliest attempt to allow the idle workstations to be utilized is command RSH machine command. The first argument names a machine and the second names a command to run. RSH run the specified command on specified machine. A processor pool is a rack full of CPUs in the machine room, which can be dynamically allocated to users on demand. The input rate is lambda, process rate is mu, mean response time is calculated. If there are n processors, each with input rate and process rate mu, if you put them together, input rate will be n lambda and process rate will be n mu. The mean response time can be calculated like this. A hybrid model, a possible compromise is to provide each user with a personal workstation and to have a processor pool in addition. For the hybrid model, even if you cannot get any processor from the processor pool, at least you have the workstation to do the work. Processor allocation, determine which process is assigned to which processor, also called load distribution. Two categories are the static load distribution, non-migratory. Once allocated, cannot move, no matter how overloaded the machine is. Dynamic load distribution is migratory, can move even if the execution is started, but the algorithm is very complex. So we are going to maximize the CPU allocation, minimize mean response time. Response ratio the amount of time it takes to run the a process on some machine. The response time of two processes on two processes is calculated. Allocation 1, process A to processor 1 and process B to processor 2. Allocation 2 is process A to processor 2 and process B to processor 1. Since allocation 1 is better assignment for minimizing the response time.